So this is the 2018 Junior Cert Higher Level Paper 2, and we're looking at question number 4. Hager takes part in a chess competition. In each game she can win, draw or lose. In each game she plays, each of these three outcomes is equally likely. So part A says write down the probability that Hager wins her first game. Well, if the three outcomes are equally likely, the probability that she wins the first game is 1/3, or 1 out of 3. Part B says fill in the table below to show the 9 possible outcomes for Hager's first 2 games. 1 is already done. LW means that she loses game 1 and wins game 2. Okay, well, it's pretty straightforward. She can win game 1 and win game 2, draw game 1 and draw game 1 and win game 2. This one's filled in. She can win game 1, draw game 2, draw game 1, draw game 2, lose game 1 and draw game 2. She can win game 1 and lose game 2, draw game 1 and lose game 2. She can lose both games. So that's the sample space filled in there. Part C says find the probability that Hager wins game 1 and loses game 2. So wins game 1 and loses game 2. Wins game 1 and loses game 2. That's this one here. So there's only one way that can happen, and it's 1 out of 9 altogether. So the probability there is 1/9, or 1 out of 9. That's the probability that she wins game 1 and loses game 2. Okay, part C2 says what's the probability that Hager wins at least one of her first 2 games? So she must win at least once. Well, to win at least once, we're talking about this option here. She wins both, that's at least once. This one, it's any of the outcomes that has a win in it, at least one win. So that's 1, 2, 3, 4, 5 out of the 9 that have at least a win in it. So the answer there is 5/9. Okay, and finally part D. Hager plays 3 games in the competition. Work out the total number of different possible outcomes for her 3 games. Okay, well, you can think of this a number of ways. One of the ways you can think about it is in terms of the fundamental principle of counting, which means that there's 3 outcomes for the first game. For each of those, there's another 3 outcomes, and for each of those, another 3. So if you multiply all of them, that's 3 cubed, which is 27. The other way to think of it is you can have your win, lose, draw on a tree diagram. Win, draw, lose, or win, lose, draw. And for the win, you can have another win, lose, draw. I won't do the rest of the tree, but you can see. And then say for that win, you have another 3 options again. You can win, lose, or draw. So draw. If I completed this tree, you would actually see you'd have your 27 outcomes there. So the answer is 27. And finally, D part 2, work out the probability that she doesn't win any of her 3 games. Well, if she doesn't win, we could list all the ways that could happen. So she could draw, draw, draw. She could draw, draw, lose. She could draw, lose, lose. She could draw, lose, draw. I think that's all the options now, beginning with draw. Then she could lose, lose, lose. She could lose, lose, draw. She could lose, draw, draw. Or she could lose all 3. And they're all the options that don't have W and don't have a win involved. So you're looking there at 8. 8 ways that she doesn't win, and that's 8 out of your total, which is 27. So for the probability, it's 8 out of 27.